Hi, my name is Catalin Petrescu. I'm a network engineer, and I'm going to talk to you about LNETD, network discovery. Just a quick introduction about myself. I'm a network engineer, as I mentioned, focus on service provider. So along the years, I changed quite a few jobs. So the need for learning the topology of my new workplace really fast came to mind. Whenever I join new companies, maybe not all of them have up-to-date diagrams or tools. So you know how that is. The ones that do have diagrams or tools, it's very hard to get them when you join. So first couple of weeks, you just sit there and do nothing pretty much. So I used to work with all three big modeling tools, so Catalin, Wandle, and Packet Design. Those are really great tools. So if you can afford those, go ahead and buy it. If not, then I look at the open source community, and there was nothing up there. And I decided, okay, let's try and see how hard can it be to build one. So I started with an ISI speaker, a parser. That was the first approach. That's not really maintained anymore, so it's just a legacy thing that you can still use. Then I look at physical devices in the network. So the three vendors that I looked are Juniper, Cisco, XR, and Nokia. So I built some modules to get that information from all the three vendors. And the last one that it's implemented recently, it's getting the topology of the network via BGP-LS with the help of Go BGP. On the front end side, it started as a fork for ENMS. So that's a cool, nice project as well. The backend, it's a Python Flask. The front end, it's a JavaScript, of course, and D3GS. And somebody did all the math for me, so I don't have to bother with that. I'm not good at math, so that was really helpful. In terms of what if scenario and traffic modeling, initially the HTML tool had that module, but I feel that it's not really good. So I took that out, and you will see in the demo, I put it into a separate tool. A little bit of history. So the project started in 2017, and it was just a plain HTML file. And now in 2020, I think we are version 104, and has a nice, pretty good. In terms of how the tool gets the topology, so I mentioned from the Juniper side is via netconf, just parses the ISIS database. And the critical thing is, of course, for each neighbor that you have, you get that particular neighbor name, and you get the IGP metric. And then the tool gets the local IP and the remote IP address of the interface and puts that into SQL database, doesn't matter which. In this example, it's an SQLite 3. So that's for Juniper. For XR, it's pretty similar. It's just netconf, and again, it parses and puts the database, the information into a database. Nokia is supported as well, and Nokia has a caveat where they are doing a clever thing with their encoding. So I work with one of the colleagues in Nokia, Roman, and thanks for that, to decode that information and get that support as well. So at the moment, it supports all the big three vendors out there. Once the information is gathered from the network, so you have the links, then it would be great to have more information in terms of traffic utilization. So the data is enriched with a couple of information. We get the in octets, out octets, interface speed, and if index. Once that is done, of course, you can just display this into a nice topology mapping. So it supports parallel link, as I mentioned, and it also supports some interaction. So you can click on the node and get live information or 24-hour traffic information. And I will go through that in the demo shortly. The other thing that the tool is capable of doing is, of course, having the full network view. It's very easy to ask the network to give you some shortest path between two nodes. So that's what's explained here. You can activate this toggle and select two nodes, and it will display you the path that the traffic might take into the network. So this is IGP cost-based traffic. Having all the network, the links, the nodes, and mapping that to POP, you can get some presentation about the capacity between your POPs if you want to. So this is one of the features you can get utilization between POP A and POP B. You can get a pretty map of where the POPs are located and how much capacity you have in those POPs. Once IGP information was done and I could display that, then I looked at external topology. So I'm a big fan of PHP weather map, and I think everyone is at some point has worked with that. So I wanted to replicate that for external topology. So you can build your own topology and then display that utilization into the tool, so you can get information about utilization. Of course, you can also parse net flow data and just do a Shanky diagram, and it will display you where the traffic flows. Another feature is device inventory. So this is based on custom parsers logging into the devices, because we already discovered the devices from the IGP topology, and model the chassis with interfaces, what's up, down, and so on and so forth. Two other modules that were requested by the community was the BGP topology. It's always nice to have the IGP topology. It's useful to have the BGP view as well, so you can see how the IBGP topology is done, where the route deflectors are, and that's discovered as well. There is a module for traffic forecast using a Facebook library as well. The what if scenario and what happens if I want to add or remove a link from the network, and how the traffic flows, how the failure analysis work, initially was in the web interface. And as I mentioned, I took that out and moved it to a different application. That one just imports the topology from the web application, and we can go into the demo and I will show you how that works. Of course, it wouldn't be a what if analysis if you can't import demands. So traffic demands, you can import that from PMACT or Cantic, or you just put them manually, and that will be displayed on the topology. So in summary, the what if scenario has adding, removing links, nodes, changing magic capacity, and also a layer 1 topology mapping. And I will go through that into the demo as well. That's all the slide. I tried to jump through them so we can go to the live demo, and hopefully nothing breaks and we can have that. So let me close this one, and hopefully I get a confirmation that my browser is displaying correctly and on my desktop.
Yeah, we can see that.
Perfect. So this is the LNET web GUI, so the web one. So you can see it. We have some dashboards, some tabs here, dashboards and network topology. So for the moment, because we didn't discover anything, it's pretty much empty. So we'll go and generate some traffic, because without traffic, not much, it would be a dull demo. And try to discover the routers first. So this one will go to one of the lab devices, hopefully, and get the information that I described in the slides, and update the database, which it did. So now if we go back to the dashboard now, you can see we discover 8 routers in our network, and the distribution is 7 Junipers and 1 Cisco XR. We have per country, how many we have. So in UK, we have three routers. The prefixes and links are still not discovered. So the routers have their IP address, the vendor, and their location, which is derived from the host name. we'll go ahead and discover the links as well. And hopefully by this time the generating traffic is there. And we'll go ahead and just discover the prefixes as well. So all is based on queries to a lab device using netconf and parsing that information, putting that into a database and enrich that as I mentioned. So at the moment we have both the routers, links, and prefixes discovered. So if we go back to the tool, and we'll see we discovered 10 links and 12 v4 prefixes. These are getting populated here in the dashboard, so you can see the links per router and prefixes per router. We went through the routers. The links information is just source, destination, local IP, and metric information. So you can check the metric information. The capacity at the moment is 10 meg and 100 meg links. All your IGP prefixes should be here. So hopefully, if you put a lot of IGP prefixes there, and hopefully Cloudflare is not in the audience. I see Cloudflare there, and okay, Google is there as well. Some networks put their IGP, some more prefixes in IGP, so that's useful to have information about that. So that will be the dashboard, but of course I talked about the diagrams and how to discover the network. Once the links are discovered, you can have the network, and of course it supports drag and drop, zoom in, zoom out. Can arrange the topology as you see fit, and probably that's one of the tasks for that. It will take you a while to arrange, so let me try and arrange this as much as possible. And you can save the layout, of course, and then next time you go into the topology, it's there. So as I mentioned, you have information about it. You can hover over a neighbor and it will tell you all the information about it. So it will show you the neighbors, the interfaces. If we zoom into this one, for example, it will tell you this interface. You can click on the interface and you get some utilization. Of course, this being a demo, you don't get much, but you can see, you can go back in time and check the live utilization. And once the script to generate is completed, and let me check if that's done. I think that's enough. We can rediscover the links, and hopefully the generated traffic is reflected there as well. So the links were rediscovered, so you can do this in a cron tab, and then I should have left it for a longer period, but you can see the traffic has increased based on the generated traffic, so you can get real information about the past traffic. You can see when I did some other testing here. So that's the network view. We can also get some aggregated network view. So if you only care about POPs and you really don't care about a view of your entire network, you just want to see how your POPs are connected, that's on the aggregate topology. And of course, you can save that topology as well. I'll just jump back to the IGP topology and show you the shortest path. So if you want to see how your traffic flows between two nodes in the network, you select two nodes and the black dot links are showing the traffic. So you can see this one is only using one of the links, and that's because the second one has a high metric. So you can, at a glance, see how your traffic flows. Of course, this is a small network. So going back to the aggregated topology, you can see between nodes, between your POPs And you can see here we have two links between UK and France, and that's showed there. Of course, if you have multiple links between nodes, you probably don't want to see all of them, so you just want to see one aggregated, and this is where the other tab comes into place. So now it's just one link there, and you can see the capacity has been increased to 20. So instead of showing you two links of 10 meg each, it will show an aggregate of 20 megs. In terms of other features, topology filtering is there for big networks. You can just on the fly select what you want. So you want UK to France, for example, or it supports regex, and you can do that. It's not useful for small networks, but I will give you an example of closed topology where there are multiple nodes. So let me do this on the level side. So here we have a closed topology, spine, leaves, super spine, and only with this one in mind, it's going to be pretty hard to get the information you want. So now that I save the topology, we can go back and look at it and see how it's displayed. So if you just want to find out how my spine connect to a leaf, you can get that information. If you only want to see how all the spine connect to a leaf 4, for example, you get that that information there. Again, it's custom. You can zoom in, zoom out, move, and save the topology as you see fit. That's on the IGP topology, and the two things that I wanted to go over you in this demo for the web is the pop-to-pop capacity, which is, as I mentioned, information about traffic between two of your POPs. So for example, if I select France, UK and France for the last week, I should get information about last week traffic, and you can see being a demo, it's not that much. You see the capacity that we have 20 megs between the two POPs, and then the utilization, which is 0, of course. You can see the year aggregate, and you can look back in months, weeks, or 24 hours. This is all customizable, and you can see where I try to do some demonstration as well. You can see individual links. So if you remember, the two POPs had 2 links between them. So you can see those links and their capacity, and also individual traffic links. The POP capacity is just a display of where your POPs are and how much capacity you have in and out of the POP, and GPS coordinates. So your NOC can easily, or your team can easily see where your POP is, for example. Here. The last two things are the external topology, and again, you see this one has updated finally the traffic utilization. So again, you have the option to add your own transit providers or peers or whatever external information you're looking at, and save the layout. And now if we go back to the external topology, now you can see this interface with transit 1. On the outbound, it's 30% utilization. So you can click on it and see what happens. So of course, what happened was me generating some dummy traffic on the network. So you get in and out information. So on this one, on the CDN, you see the outbound, it's blue, so not that much utilization. The inbound, it's green. You can get the external, but you can also get the full information. So this will add your IGP information. So you just, of course, again, have to arrange them in a fashion that makes sense for you. So for example, the IGP information between, IGP traffic between these two nodes has increased to 70%. And at a glance, you can see where maybe my traffic came from CDN1 and then went to this router and this one. and so on. And you can troubleshoot further how that works. So that's the external information. The last one on the web is the BGP topology. So when you join the company, it's good to have the BGP view as well. So we can look at iBGP topology. So you can easily see at a glance where the router vectors are in this topology. Of course, you can save it. You'll see two of the routers having some clients, so you can give us where the routing vectors are. You can also see the external topology if that's, zooming out of that. You can see which peers are down, which peers are up, and so on and so forth. It's useful for the NOC and for operation as well.
Hi, Catalin.
Yes.
You only have 2 minutes remaining, including question and answers.
Okay.
Thanks.
Thanks. So the last one, oh, I'm so sorry. I should have taken my time. The last one I wanted to highlight is the what if scenario. So in this one, you can import your topology. And you can see it's similar to the one that we had in the web. And here you can just add some of the demands between two nodes. So we'll just add 5 meg of traffic, or let's add 10 megs of traffic, because we are running out of time. Between this router, and let me zoom in, between this router and this router. So you see the traffic utilization on the link. So this one is a 10 meg link, so it's 100% utilization. This is a load balanced link, so 50%. And you see here, the traffic is really not load balancing, so only one link is utilized. We can go ahead and see what happens if you change the metric on this one. You see the utilization is there. So because we are running out of time, I'm just jumping through a couple of scenarios. So imagine you want to add a node in the network, and then let's say in France, you got a new router that you want to put. You add some interfaces and you connect that to Netherlands. Then from there, you decide, okay, I want to, let's see what happens if I add an interface to direct it to Nairobi, to Kenya. So you can see on the fly, the traffic moves, and traffic now flows from here through this new link and down. Of course, you can just shut down the link and traffic will flow through the remaining links. Or if you do multiple failures, then at some point the model will say, I can't deploy the traffic, so something must be wrong there. You can bring a node up. You can add multiple interfaces between nodes and see how the traffic flows. You see this interface is still down, so let me bring that up. The interface at the moment is 100% utilization. So you can increase the capacity there. So if we add 100 meg capacity, that will change and the traffic will be routed through this link, but now the model shows 10% utilization on that interface.
Hi, Catalin.
Yes.
Sorry to cut in again. We are out of time.
Okay, thank you for that. And I think that's all from my side. Unfortunately, some of the models I can't display, but if there are any questions, I'm happy to answer. So let me.
I have one question from the floor, and it's from Jody Botham. How easy is it to add support for other vendors?
Well, now that there is a BGP-LS module, as long as you have a BGP-LS speaker, then the topology can be retrieved via that protocol.
Okay, thank you. I don't have any further questions from the floor at this point.